Hey everyone, today we're going to solve this LeetCode question that is 2300 successful pairs of spells and potions. It's a medium level problem and it has a very good like to dislike ratio. As you can see, almost 1600 likes and only 35 dislikes. And it's a pretty latest problem, so I will say that this problem is good. And because by looking at the recent interview DSA technical rounds, the recent problems are often asked in these interviews, in DSA interviews. So anyways, let's start the question. So we are given two positive arrays. So one is spells and the other one is potions of length n and m respectively, where spells of I represents the strength of ith spell, okay, and potions j represents the strength of the jth potion. You are also given an integer, that is success. A spell and potion pair is considered successful if the product of their strengths is at least success. Okay, so we need to return an integer pairs of length n, where pairs of I is the number of potions that will form a successful pair with the ith spell. Okay, so let's look at this second example. So we are given these spells, and that are 3, 1 and 2, and we are also given potions that are 8, 5 and 8. By the way, spells and potions, they are of same quantity, that is 3 and 3, but it's given in the question that they can be in different quantity, for example n and m respectively. And the success factor, or just success, the threshold amount is 16. So now we have to generate an answer. So first of all, we need to understand this graphically. So there's a spell, right? I don't know how to represent a spell, but this is a potion, okay, and there is something in it, and this is a potion. Now let's say this is a spell that has been casted onto this potion, and now the strength of this potion is increased. So this is basically the visual representation. So initially the strength of the potion was 8, but now with casting this ith spell, the strength of this 8th potion is now 24. That is their product, right? And the similar way, this is 24 when we are casting spells of 0th spell, that is the third strength, and the strength of this potion is 3 times 5, that is 15. The strength of this potion is 8 times 3, that is 24. And again we need to do this thing for this time as well. Now to calculate the answer, there is a brute force way, and the brute force way is, so the brute force way is to consider every case, right? So for example, s of 0, s of 1 and s of 2. So s of 0 is nothing but 3. In this case, the potions will be equal to 24, the strength of the 0th potion. These are indexes. So strength of the 0th potion is going to be 24, and strength of the second potion is going to be, so we are basically multiplying the whole thing with 3. So 3 into 8, 24, 3 into 5, 15, 3 into 8, 24, right? And at this time we are multiplying it by 1, which is 8, 5 and 8. And this time we are again multiplying it with 3, which is 24, 15 and 24. Fine. Now after this fact, now you can make this observation that with 3 you will have, now this is an answer array or the pairs array that you need to return, and for every ith potion you need to give some answer, that how many potions are above or at least equal to, are at least they have the success at least equal to the given value, that is the threshold amount. So we have 0, 1, 2, these are the potions, and let's see, sorry, these are the spells. For 0th spell, third, how many potions are there that will have value above 16? So we only have 2, that is 24 and 24. 15 is less than the success that we are looking for, so we are not going to accept it, so we only have 2. In this case we have 0, right? We will be writing 0 here, and in this case we again have 2, so this is 2, 0, 2, and that is our answer. Now You can do this in a brute force way. So you will be iterating over these elements, and then you will be iterating over the portions and multiplying it them. And while multiplying, you will be keeping a counter if that value that is multiplied, the product, is greater than the success threshold or not. And if it is greater than that, you will count it as your answer and you will store it. And the counter for every iteration of spell will be stored and pushed into this answer array. So as you can see, this is a brute force method, and if spells is n and m is the number of potions, then this is going to be time complexity is order of n into m, and the auxiliary space complexity is constant, although we are returning a, in the function we are using like an answer array, but the auxiliary space, which means something that is not required because we need to return it, so that's an obvious thing. But other than that, we are not using anything, so that's a constant space, auxiliary space, and this is the time. But this is a brute force, right? And is there any optimized way? Yes, it is. And the second way, the optimized one, is something that is called binary search. And how to do it? So for example, the spells that are given to us are, in this case, let's take this example, the first one, 5, 1 and 3, and the potions that are given to you are 1, 2, 3, 4 and 5, right? Their indexes are, so this is 0th spell, first, second, and this is 0th, first, second, third, fourth potion. Now the success is, the threshold amount is 7. Okay, now what I'll do is, I will, first of all, it's not given in the problem that the potion array is sorted, so I need to sort the array. So after sorting the array, the potions array, I will go for the, so after sorting the array, the potions array, now for every spell I will try to calculate, or I try to find the value which is greater than, which is greater than this success value, because every value, so because this is the sorted value. Okay, I will give you a test case. I will dry run it for you and then you will understand it perfectly. So for example, let's give it a dry run. So yeah, now we have s of 0 and s of 0 is 5, and for 5, in this case, I'll not multiply right now, but I'll do a binary search. The binary search is that we have 1, 2, 3, 4 and 5. Okay, this is your window, right? This is your window and this is the middle element. This is your low and this is your high. Okay, now the middle element has to be multiplied. So middle element is 3 multiplied by the spell value, that is 5, and this will give you 15. Is 15 greater than the threshold value? Yes, it is greater than the threshold value. And if it is greater than it, then you will make a comparison. Does the value on the left side of it is smaller? So there will be two cases now. Actually, there will be three cases, but in general, there are two cases. The two cases are, the two cases will be, so if the middle value, right, the portions of middle value is greater than 15, actually no, it's not greater than, actually it's so if it is less than 15, or the success value, right, if this is the case, then you will know, then you know what, let me just, yeah, so if this is the case that the middle value is less than the threshold value, which means now you need to find the middle value which is greater than the elements. You need to find great elements, bigger elements, because the elements that you are studying currently are smaller, and every element on the left side of this element, let's say this is the number array, and now you are on this element currently, and this is a smaller array, smaller element, because it's a sorted array, so every element on the left side of it will be smaller. But you need bigger elements, right, because this is not something that is acceptable. The perfect equation is has to be greater than or equal to the success rate. So this is the equation that we need to achieve. And if this is the case, then you need to shift your window. So originally your window was like this, but now you need to shift your window to this part. You only need to consider this part, not the whole part. Why? Because you need bigger elements. So if this is the case, then I will say that high value, actually low value, is equal to mid plus 1. right? Now there's another case. The other case is, so if, yeah, the other case is if the window, and we need smaller elements. How you will know that you need smaller elements? So if the p of mid is greater than or equal to s, right? But the element that is on the left side of it, that is p of mid minus 1, is also greater than or equal to s, right? So if this is the case, then you will know that for this particular case I need smaller values, because the window that I am currently searching and the current focused element is greater, and the element, and there are elements on the left side of it that are smaller than the concentrated element, but they are still bigger than the threshold element, which means we are in general in the land of elements which are bigger than the threshold value, and we need to squeeze that. So I will say high should be, because now we are squeezing the window. So for example, this is a window, but now we are looking at this window, the smaller elements. So initially we were this elements, and if we want this window, then low is equal to mid plus 1, but for this case we have to high is equal to mid minus 1. So this will be high of mid minus 1, right? Now after this part, now there's another case, the other case is the remaining case where the mid value p of mid is less than or equal to s, and the p of mid minus 1 is smaller than s. And if this is the case, then we are good, then we will return our answer, and the answer will be the total elements minus the current mid, right? That is going to be our answer. So in this case, so this is the case, and the time complexity is going to be equal to, so we are iterating. So first of all we are sorting, right, the portions array, and that is equal to, so the portions array is what is the size, m. Okay, so m log of m, that is the sorting of the portion array. And the second part is the iterating over each element, iterating over n elements, and doing a binary search for every n element. But the binary search is applied on the portions array which has a size of m, and that is why it's log of m. So it's m log m plus n log m. This is the time complexity, and space complexity is constant. Auxiliary space complexity is constant. The space complexity in general will be equal to linear, because we are not linear actually, it's equal to m. No, it's equal to n actually, but the auxiliary space is constant. So yeah, this is the uh, solution. Now let's code this up. So first thing first, we need to sort the portions array. Portions dot begin, portions dot end. Now vector of int, and this is the answer that we are looking for. Now we need to iterate over the spell, and we will be focusing on each spell. And in that, what we are doing is, so answer dot pushback, we are using a function that is solve, and we are providing some things. So first is the spell, the second thing will be success, the other thing is potions, and I guess that is it. Yes, and after this we have to return the answer array. Now in this case, the solve function is going to return an integer value, so it's a int solve. The first thing is a spell, second thing is a long success variable, then you have a reference of vector int potions. Now in this function you have some variables for binary search, and that is low, that is initialized with 0, mid doesn't have a value right now, high is equal to portions dot size, or you know what, portions dot size. Yeah, we have another variable that is n is equal to portions dot size, and high is equal to n minus 1. Actually m, it should be m, so that it's not confused with the size of spells. Yes, now I think it makes sense. So let's write the algorithm for the binary search. So binary search is low less than equal to high. Then we need a mid variable. Mid variable is equal to low plus of high minus low. If you are not familiar with this formula, then you can solve this up, and it is nothing but low plus high whole divided by 2. I'm writing this to avoid integer overflow errors. You can also, I think so, that you can 10 per 5. Uh, yeah, I think you can use the low plus high as well, so it's not going to be an integer overflow. Now the thing that the cases that I have told you earlier, these are the cases that we need to take care of. So first is p of mid, that is the portions of mid is less than s. So if so we need to find is the success, right? So I will create a function that will give me a success value, not a success value, but a true or false value, that is it going to be successful or not, right? Because a success value is associated with the threshold amount. So for example, a spell is product or multiplied with a potion. Now their result is greater than the threshold success, then it is a success and we will return true in this function. But if it is not, then we'll return false. So we need to create this function, and that is a Boolean function. Now there are some things that this function will take. So let me write down this here first. So first is the spell, right? Then we need to pass the threshold success, then the mid value, and potions. You know what, we can actually say the potion only. Yes. And potion will be nothing but potions of mid, right? Now if this will return a true value, then it's different, but if this will return a false value, then we need to search on bigger elements. So bigger elements means low is equal to mid plus 1. But first let's write this function. So we have int spell, then we have long success, and at last we have int potion. Now the return value is, so this is a long typecasting so that we don't go into the overflow issue. Now spell is there, it's multiplied with success, well success, not success actually, potion, and then we need to make a comparison if it is greater than or equal to the threshold success, and if it is, then we'll return true, and if it is not, then it will return false. Now we have another condition, and that is if the the success of this potion by this spell is greater than s, and it is greater than the element on the left side of it is also greater than the s, then we need to shrink our values and focus on values that are smaller than the current ones. So for that means if is success of spell and potions made is true, and we are going to copy paste this up, but this time it will be mid -1, but we need to make sure that we don't go into this index errors. So I'll say mid -1 is greater than equal to 0, right? Yes. Now I will say high is equal to mid -1, and in else condition, if everything is fine, then we'll simply return the total elements. Now total elements is equal to m minus of mid. Okay, and let's say nothing works out, the binary search, or we don't find our values, then we'll return 0, because if the binary search is not working, then it certainly means that we don't have any spell that is in the eligible criteria, so we'll return 0. And yes, I think, well, seems good, so let's give it a try. Okay, it's passing the given test cases. Sweet. Okay. Well, we are not going to submit it again, but I guess it's all right. Yeah, the same thing. Sorting the positions and then using the for loop and then applying the binary search. I mean, they are not using functions, but I am. And I don't think so that it's a bad thing to use function because it makes more sense, I guess. And the code is more subtle and easy to understand. Yeah, so this is the problem. And the time and space complexity I have discussed, m log m plus n log m, and the auxiliary space is constant. So this is a problem, and I think this is the most optimized way to solve it by using a binary search. Other than that, if you have any suggestions, you can let me know. And if you still have any doubts, you can let me know in the comment sections. Thanks for watching and have a good day.